Hello, Dr. J here. I'll be going over the 555 IC timer. Again, this is a very brief introduction. This is a introduction to engineering. That's why we're not going to go into the block diagram in detail for this course, but in later courses we can talk about the detailed intricacies of the 555 timer. All we're going to show you right now is how a circuit is put together to build you the monostable operation and the astable operation. So let's start off with the astable operation. Here's a circuit from Multisim, and I have a handout how to obtain this circuit so you can run it and try different resistor values to control the oscillations of this device. We have external components R1, R2, which are the resistors, the timing resistors, and we have the discharge and charging capacitor C1. Shown here is the oscilloscope, and the oscilloscope is used to display two outputs. We're going to see the output from pin 3, as well as in channel B we'll be seeing the voltage across the capacitor. Also shown here is like you can add a flashing LED and a buzzer sound. For learning modes 5, when you actually build this circuit using the Elvis hardware, you won't need to attach a buzzer to it, but you will be using the LED to see it flash in both cases. So let me show you the output coming from this device. Let me run it, and it's going to plot it. So you can see here is the discharge capacitor, and the blue line outlines the output of pin 3. Again, this is the oscillations coming out of this 555. The blue line corresponds to pin 3, and this triangular type shape waveform denotes the voltage across this capacitor. You should have seen this earlier when we're dealing with RC circuits. And the threshold values is used to determine the frequency and timing of this device. So we have threshold points for the capacitor here, and inside the circuitry they sense these voltage levels so that they can provide the proper amount of period to give a certain frequency. In the next slide I'll show you the formula in terms of R1, R2, and C1. So here's the basic formula of the frequency, and from the frequency you can get the timing equation, T, or the period. The equation reads 1.443 divided by R1 plus 2R2 times this quantity multiplied by the capacitor. This is the formula for a monostable 555 operation where we don't have R2 anymore, and this will help you determine how long or time delay that this 555 timer will generate. So here's a monostable operation. Again, this is from Multisim where I got rid of the R2 resistor, so we have a resistor R1 of 50 kilo ohms and a capacitor C1 of 100 microfarads. Notice I have put a signal generator here. It has a starting frequency of 2 Hz, 50% duty cycle, and 10 volts V peak. And because of the formula 1.1 times R1 times C1, when you multiply the 50 kilo ohm by the 100 microfarad and then multiply it by 1.1, you get a timing delay of 5.5 seconds. So let me start the simulation. It's going to take some time, so be patient a little bit, and then once it gets started it should start plotting this IC timer. So right here in the red is the voltage across the capacitor C1, and this timing interval right here is from pin 3 of the 555. I'm plotting it so that it will just trigger it and will plot this waveform once. Right, let me pause it now, and you can see here I have two cursors that I can use for the timing, so I'll put one right here and one right here. Hence, what you should see is a timing interval. Let me put that right here, of 5.379 seconds. Let's try. Okay, I can see this is slightly off, so this is about 5.5 seconds. Let's try another one. And the first one right here, and the timing difference. So basically, when you have these two cursors, it will give you the time difference between this, and we read 5.5 seconds based on this timer. Okay, so that's the result. Now, if I change the frequency, let's say 20 hertz, we should get the same result, because once the monostable starts, it ignores all other pulses that follow the initial trigger pulse. So let's try it again. I'll start the simulation, and we should get the same result, even if it's 20 hertz. Because once it starts to trigger, then it'll just start charging and ignore also any follow-on pulses. So you should try that when you get to part 2 of this laboratory project. All right, let me pause, and then let's look at the cursor again and see if it looks like 5.5 seconds. So there's one right here. Another one right here. And the time difference between these two cursors is 5.53 seconds. Not bad. So that's how the monostable operation works. And you can use these time cursors to help you determine the time delay for this 555 timer.